Welcome to Coffee Break with Microchip Technology. Coffee Break is our ongoing forum in which we discuss new and evolving technology, all in about the amount of time it takes to drink a cup of coffee. I'm your host, Eric Gladfelter. A word about our broadcast today. We do have a remote host. If our video feed gets a little less than optimal, we may put up a still picture of our guest. So if you see that, don't be alarmed, don't be surprised. Not remote and in the studio with us is our moderator, Aaliyah Fahout. Aaliyah, welcome back.
Thank you. And hi everyone, thanks for joining us today. We are currently live on YouTube, Facebook, and LinkedIn. You can participate in today's episode by leaving your questions and comments in the chat, or you can email us at livestream@microchip.com after the broadcast. Don't forget to follow us on LinkedIn and subscribe to our YouTube channel. Back to you, Eric.
Thanks, Aaliyah. On to our topic for today, trusted time for zero trust networks. Joining us is Paul Skoog, product marketer here at Microchip. Paul, welcome to the program.
Thank you, Eric. Happy to join you here this morning.
All right, let's get on to our topic. Before we dive into some of the details, can you help us understand some of these concepts that we're talking about? Trusted time to start with.
Yeah, for sure. The topic here is kind of has two concepts, right? There's this concept of trusted time, and then this concept of zero trust networks. And you may not know what either of them actually is, but the little logo down below that shows the Acropolis. If you're familiar with zero trust networks, that is going to be familiar to you. It has these pillars, if you will. We'll get into that. And then you can see there's a pillar there, and it coming out of that pillar is a time server. And so what we're going to cover is how a time server does matter, providing time into a zero trust network.
All right. So let's talk more detail. Tell us what zero trust really means and what a zero trust network or zero trust architecture is.
Yeah, so zero trust kind of has two main components. The first one is it's a cybersecurity paradigm that, or philosophy, if you will, or a way of looking at things, where trust is never granted implicitly. You may see me and go, I think that's Paul, but you asked for my driver's license or my passport. Similarly, we go to log into a network and we provide our credentials. But then again, we might do some sort of two-factor authentication where it sends something to our phone just to make sure we are who we say we are. No implicit trust granted at all. Then we get into a zero trust architecture. That gets into something having to do with end-to-end approach to verifying who we are and how we get authenticated to the resource we want. How that came about, in the old days, there was a perimeter. You went into the office and you sat down, you logged in, you gave your credentials, and you're on the network, and you can go or do whatever you want, okay? That didn't work too well. People can hack into the network, or you can have some fraudulent activity happening inside that perimeter. So particularly with all the remote workers these days, we just don't go with perimeters. We go with end-to-end. We're going to authenticate a user where they are, and we're going to authenticate them to the resource that they're trying to access. Because we kind of assume in zero trust that the network's already been compromised, and there's actually a motto. It says, never trust, always verify.
Okay. All right. So with these concepts, now if we're designing a system, complex system here, why would a system designer need to care about these paradigms and these terms?
Yeah, that's a great question. It kind of distills down to, who cares about these sorts of things, right? Well, zero trust has been around for over 10 years. Very large organizations have adopted it and deploying it. Even Microchip's doing that. But here a couple of years ago, the federal government said, we're going to go to zero trust. And so the president issued a memorandum, and these executive orders fly at a high level. But ironically, buried in this thing, and it's not that long of a memorandum, it talked about the importance of log files and network forensics. And so, of course, one memorandum spawns another memorandum, if you will. And the next one was about a 44-page memorandum that had to do a lot with log files and time and how critical it is and where you get your time, like from GPS, and, don't trust time from the internet and that sort of thing. And so why is all this there? Because it turns out that accurate time for log files is really important for network forensics. If you're an IT guy and something goes wrong, you're really going to rely on network management reports, and those reports are built up from log file aggregation from servers, workstations, routers, and so forth.
Okay. So with these memorandums, one of the things in there is don't use public time servers. Why not? What are the issues? What are the concerns with public time servers?
Well, that's a good question. It turns out if you're going to use a public time server, it's on the internet, all you really know is an IP address. And you are granting implicit trust to that IP address that it's going to provide accurate, reliable, secure time for your network and your zero trust architecture and everything else. So it fundamentally violates the paradigm of you're granting implicit trust to an IP address on the internet somewhere. So
okay.
Yeah.
All right, so we've talked about the concepts and why it matters. Let's look at a zero trust model. What are the elements? What are the key elements that need to be considered in this model?
Yeah, so they call it a zero trust architecture, so they conveniently come up with a structure. In this case, they picked an Acropolis because there's all these different pillars, if you will, that hold up zero trust. And if you think about what a pillar is here, they've got like users. So we got to verify users, to access the network. We have to verify devices like your phone or your laptop or whatever to the network. And it goes on. Applications like NTP, Network Time Protocol. It has to be authenticated and verified. All the way up to analytics. Analytics aggregate a lot of log information to help in network diagnosis for forensics and things like that. So you find that there's a lot of fundamental data that's needed to support these various aspects of zero trust architecture. But then you find you need accurate and precise time because it gets back to those log files. Log files document the who, what, when, and where of all this activity. So fundamentally you find that if you need that accurate and precise time, you need a really good time server that fits into the zero trust model. And that's where you can see the Microchip sync server there, kind of as a foundational element to zero trust.
Okay, so now, Paul, you can probably hear me chuckling a little bit. Even in the world of engineering, log files sound pretty mundane. They really that important in this model?
Yeah, it's almost anticlimactic. But yes. Log files are dull. I confess, this is true. I wish they were glamorous and everyone had a full appreciation for them. But in truth, it's just an essential part of a log. If you don't have good log file timestamps, your logs aren't going to write. They're going to correlate right, and that means your management report isn't going to work right. And if you're the IT guy, it's going to be a headache. And so, log file aggravation with accurate timestamps makes life better.
Okay. So what does Microchip provide that helps our IT people not have headaches? What do we contribute to dealing with these issues?
That's a good question. So when we look at the sync server in a zero trust environment, there's a sync server right there, by the way. You see the front and the back of it. It's a clock. It's accurate to about 15 billionths of a second, 15 nanoseconds, and it provides very accurate time using the NTP application into that zero trust architecture, if you will. So it's an application that works out there and it has to be secure and verified and so forth. But at the same time, it is a network device and therefore it is implicitly untrusted. And so it has to fit into the devices category where it becomes a trusted device connected to the network and everything else. And so this is where we begin to see this connection between trusted time and a zero trust network, because the two really need to be interconnected and working well together.
Okay, and where does the sync server sit within sort of the overall architecture of the system?
Yeah, so NIST came out with a publication, 800-207, I think it is, Zero Trust Architectures, and they kind of divided the network, if you will, into two parts. They have a data plane, okay, and that would be the plane that we operate on, right? We log in and we go to applications and we connect our phone and everything else, and the sync server synchronizes all the time on the workstations, routers, servers down on the data plane, okay? But in a zero trust architecture, this NIST specification also calls out a control plane. These are the facilities and functions, if you will, that are behind the scenes that do things like ID management, making sure who I am and who you are, and we're allowed the different resources. There's the security information and event management systems, network management systems that monitor all the logs of what's going on, PKI infrastructure, and so forth. So where the sync server fits in so beautifully here is it does a great job of synchronizing all the things happening on the data plane, but also really connecting in well with the control plane. And so as a result, you end up with trusted time for a zero trust network or zero trust architecture, and providing accurate, secure, and reliable time into that architecture.
All right,
So there you have it.
So if somebody wanted to learn more about the sync server, where would they go?
Yeah, so what I would do, the easiest thing to do, is to just go to a search engine, type in Microchip Trusted Time, Zero Trust Network Sync Server. It'll pop right up. We have a solutions page. It'll pop up easily on search, and it gives you all kinds of application notes on zero trust and time and different verticals like data centers and financial, and everything you're going to need to learn more.
All right, excellent. Paul, thanks so much for the overview. At this point, let's go to Aaliyah and see if we have questions from our audience today.
Yes, we have one question today. First one is there a standard defining zero trust?
Yeah, so it would be a zero trust architecture. It comes from NIST, and it's 800-207, and it kind of puts forth the various things you have to consider, how you roll it out, and so forth. But that's the framework put forth actually by the government in terms of how to approach a zero trust architecture. NIST 800-207.
Awesome, thanks, Paul. Second question is, what makes the sync server trusted time?
Well, it's a multiple of things. It has to do with, do you trust the actual time, the timestamps, where you're getting the time from? Is it verified and accurate? And then do you trust it in the network? And sync servers are very accurate, reliable, and secure, because you want to be able to get the time and know you're getting it from a reliable and secure source, because you're depending on it so much in a zero trust architecture. It's a very foundational thing. And by the way, I think, also mentioning what helps make it is we're getting our time from the GNSS satellite system, which is a very accurate source of time. Helps in the trust.
Awesome, thank you. Third question is, where does the sync server get its time?
Oh, well, I just answered that, actually. So right now, it's getting its time primarily from the GNSS satellite system. The satellites orbiting the Earth all have very accurate clocks. We're able to derive time from that. And then you can have backup alternative sources of time in the event you don't want to use GPS. We can get it from other time sources as well. So that's a configurable part of the time server.
All right, great. Next question is, what resources are available to learn more about this?
Yeah, as I mentioned, there's a bunch out there. You can just go to a search engine, Microchip Sync Server or Microchip Server Trusted Time, and it'll either take you to the solutions page for Trusted Time. A lot of what I talked about today is documented out there, and some good app notes to read and learn more about it. A lot of the features, software features and functions that make it more, especially more trusted in how it connects to a network. And then you'll find, the product pages easily. Search engine will get you right to it.
All right, thanks, Paul. It looks like those are all the questions we have from the audience. Paul or Eric, do you have anything to add?
I'm good. Paul, did we wrap it up?
Oh, I think so. It was a lot of fun. Thank you, Eric, for the time.
All right.
All right. Well, for the audience, if you have additional questions or comments you'd like to send over, you can email us at livestream@microchip.com. And don't forget to follow us on LinkedIn and subscribe to our YouTube channel. Back to you, Eric.
Thanks, Aaliyah. Paul, thank you for joining us and sharing your expertise. Thank you to our audience for taking some time out of your day. Please visit us at microchip.com/coffeebreak. You can see our remaining episodes posted for the rest of the season. You can sign up for notifications. You can peruse our library of previously recorded sessions. We thank you again and see you next time.